of the earliest applications of water-sensitive urban design in residential developments in Australia was at the Lynbrook estate in Melbourne, which incorporated biofiltration swales in the median strips of roads and downstream wetlands, as Professor Tony Wong explains.
I'd like to describe to you the first estate-wide implementation of water-sensitive urban design for stormwater treatment. And this is a development out at the Lynbrook estate. The Lynbrook estate is a new greenfield development outside of Melbourne that included the implementation of a different way of delivering public open space and the road corridor. There are two pieces of technology that I'd like to share with you, and one is the adoption of a constructed wetland that is part of the park within this development. And the second one is the biofilter that was introduced into the median of the road such that stormwater from the roads are filtered through those biofilters. This enabled us to introduce stormwater treatment technology at a whole range of different scales, from the street scale to the precinct public open space scale, all of which geared towards removing contaminants close to the source for the protection of the receiving waterway. The constructed wetland, as you can see from this video here, is located towards the discharge, the bottom end of the catchment of stage 9 of the Lynbrook estate. It is there designed next to a pond that provides significant amenity for the community that lives there. What you will see in this wetland is that the vegetations almost completely cover any open water space in this system. Now, this is a deliberate design. It is to trying to facilitate uniform flow through a dense vegetated system that will deliver the most effective way of filtering out the fine pollutants that are contained in stormwater. You'll find in a design such as this that you would design the stormwater treatment measure very much as part of the landscape and the amenity of the whole area. You won't design it in a way that preclude the use by the community. It ought to be very much part of the community open space. So you see the introduction of boardwalks in here enables the community to walk through the wetland and in fact have a look at the different types of vegetation that are included in this wetland. This wetland was also designed through a series of different cells, and those cells have different depths. And through that, you will see that they will have different vegetation because of the different depth in those cells. There's good reason for that. The deeper cells with a deeper depth are often there to promote as much biological or microbes grow on the vegetations, on the stems of the vegetation below the waterline. And that's where it is most effective in removing the soluble pollutants. The shallower systems are there to try and promote lush vegetations that act as a fantastic filter to remove very fine solids through simply the process of filtering. So the ordering of those cells are equally important in the design of these wetlands. You would order it in a way whereby you would remove the solids first through the filtration, through the shallow cell, before you introduce the water to the deeper cell where you rely on the biological processes to remove the soluble contaminants. This next slide is a sequence of slides that shows the construction of the biofilter in the medium of the road. This slide shows the digging of the trench and the lining of that trench, and also locating an underdrain to collect the filtered water once it has gone through the treatment processes. That trench is then filled with the media. With this one, with our first generation biofilter before subsequent research, in fact, have enabled us to use even better material. We have used simply fine gravel as the filter material, as you can see here. You will also note that on either side of it, we landscape it such that it is sloping towards the middle. So runoff from the road would simply flow onto the filter media and then towards the middle where the trench is. We of course plant the vegetations to provide the streetscape that is required. Doesn't add to the stormwater treatment process, but very much add to the microclimate, but also in terms of how the street amenity is being delivered through this technology. This was a slide taken at the end of the construction and commencement of the other development within the city. This slide was taken in around 1999. This is a closer up to demonstrate the filter media and the planting along the edge of that filter media. We undertake experiments and demonstrate through a series of experiments in this development the scientific results and scientific performance of the biofilter. This was done in 2000, the year 2000, 2001. And in fact, the work done here provided the proof of concept and the scientific evidence that ultimately led to the implementation of a policy in Victoria around the use of biofilters in land development. It also seeded subsequent research that led to significant improvement in this technology, which is of course a subject of a previous presentation. Some of the work that we've done is to continue to monitor the ongoing performance of this system and also its maintenance requirement. This is a slide taken in 2004. As you can see, the trees are beginning to mature and the catchment is now established and it is functioning very well. And this is a slide taken in 2011 where you can see that the trees are now fully grown, providing significant microclimate benefit, but also the lush vegetation that is now part of our filtration system. So the Lynbrook estate is a fantastic example of how we move from theory to trials to the implementation of the technology at an estate-wide to now providing the proof of concept and demonstration for the whole of Victoria to adopt water-sensitive urban design and stormwater treatment throughout their new development.